So for this question, we're just going to quickly look at it using two different methods. Method 1. Okay. So method 1, whenever you deal with powers, it would be the best if you're using polar form or Euler form, okay, which is turn them into cis theta. And then you need to look at these two complex numbers. Okay, so 1 plus I and 1 minus I. 1 is here, I is here, minus I is here. They're both 45 degrees, and they're all in the first and fourth quadrant. We don't need to add or add pi or subtract pi. Okay, just directly turn them into polar form using r equals to square root of a squared plus b squared, and using tangent inverse b over a. Okay, this one is valid because they are in the first and fourth quadrant, so we can directly turn them into polar form. So 1 plus I would be root 2 cis pi over 4. 1 minus I would be root 2 cis minus pi over 4. Yeah, and then just directly plug the polar form into the equation. So 1 plus I to the power of 8n plus 1 minus I to the power of 8n will just be root 2 cis pi over 4 to the power of 8n plus root 2 cis to the power of minus pi over 4 to the power of 8n. Okay. Okay. So this is root 2 to the power of 8n. And then cis, okay, you bring the power into the angles, okay, bring the power into the argument. So that would be 8n multiplied by pi over 4, and then plus root 2 to the power of 8n, and then cis minus pi over 4 multiplied by 8n. Yeah, so root 2 to the power of 8n, root 2 to the power of 8n, you have this in common. You can just bring them together, which is 2 to the power of 4n. Right? So those two together will just be 2 to the power of 4n. And then we have cis. 8 multiplied by 1 on 4 is 2. So it's 2 pi n. And then plus cis. Again, minus 8 multiplied by 1 on 4 is minus 2 pi n. Right. So 2 pi multiplied by n and minus 2 pi multiplied by n. Yeah, so you can see this is just like a multiple of 2 pi, right? The multiple of 2 pi is exactly the same as cis 0. And this is a minus multiple of 2 pi, okay? Minus multiple of 2 pi. That's still same as cis minus 0, but it's exactly the same as cis 0. They both equals to 1. Okay? This big bracket here is 1, this big bracket here is 1. So that's 2 to the power 4n, 1 plus 1. The final answer is 2 to the power 4n plus 1. Yeah, again, don't forget those special angles. 1, I, minus 1, minus I. Their corresponding angles will be 0, pi over 2, minus pi, and minus pi over 2. Yeah, and then let's have a look at our method 2. Yeah, method 2, if we don't do it in cis forms, we can still directly do it. Yeah. 1 on I to the power of 8n plus 1 minus I to the power of 8n. So what I want to do is I want to square them first. So I want to have 1 plus I squared. Because 1 squared is 1, I squared is minus 1. 1 minus 1, they cancel each other out. And you need to remember 1 squared is 1. I squared equals to minus 1. So a squared plus b squared, these two just cancelled. Okay. And then if you take out the 2, you're left with a 4n. And then here is 1 minus I squared. If you take out the 2, again you're left with 4n. So 1 squared cancelled. This just become 2i to the power 4n. And this bracket left with minus 2i to the power 4n. Yeah, and then we'll just bring the 4 inside first. So 2i to the power 4 plus minus 2i to the power 4. So it doesn't matter it's I to the power 4 or minus I to the power 4. They're all just equals to 1, right? I to the power 4 or minus I to the power 4. In the end, they're all equal to 1. So that just becomes 16 to the power of n plus 16 to the power of n. Yeah, so 2 multiplied by 16 to the power of n is 2 multiplied by 2 to the power of 4 to the power of n. The final answer is 2 to the power of 4n plus 1.